So let's talk about unpacking, right? What unpacking actually is. How does it help with classification? So when you think about objects, you think about things like, archives, for example. That's a good example of a compressed object that needs to be unpacked, right? An archive, like a zip, is something everybody's probably encountered more than once. So archivers compress many different files within themselves, and they kind of bundle them together. That's kind of the point of what an archive actually is. So by extracting or unpacking from an archive, you would get additional files. So let's say this, archive has an image within itself, and let's say it has other files as well. And let's say that one of those other files is an Office document as well. So you have an archive, it has one layer of packing at this point, and once you unpack this zip, you get an image, you get a document. But since we do recursive analysis and recursive unpacking, these documents can also have additional files embedded within them as well. So from that document, let's say we got an executable file, right? Which is a Windows format, which is actual code. To be able to classify and say, well, this archive is malicious or not, you really have to go and analyze every single layer of packing, right? So you need to say, well, on the zip level, I'm not yet sure if this file is malicious or not. The JPEG is not really malicious. The document itself, again, no scripts, nothing else on its level, which is malicious, but then I get to the executable. And let's say this executable is a backdoor. It's a known malicious threat. So let's say this file is actually malicious, right? What does that mean for all of the files which actually contain that backdoor, right? Are they malicious as well? And we say yes. So anything which is capable of deploying malicious code is something we consider malicious, which would mean that if this is a relationship tree, right, a zip file contains a document which contains an executable file, we have to go back, right? And you have to do the backtracing and say, okay, well, since this document contains a malicious file, backdoor in this case, it's also malicious, and since this document is contained within the zip archive is also malicious. So this process of classification, going from one file to another, is something we call propagation. And this propagation is, in this case, going from child to parent to container, right? All of these files in this particular chain are going to be considered malicious. But what type of malicious? That's also an important question. So how do we, then say what threat name is best attributed to this particular threat, right? So ReversingLabs uses 12 different classification engines, and they're all static analysis classification engines. There's signatures, there's machine learning, there's file similarities, and so on, right? All of these classification technologies can yet determine what type of a threat this is. So let's say that this file has 4 different classifications, right? 4 different engines out of those 12 have decided that this file is malicious. So since we know this is a backdoor, let's say we have a signature, right? Let's have a signature, and that this signature identifies this file as a backdoor. And let's say that the name that signature assigns to the file is win32.backdoor.imsecureat. Right? So that's the name which uniquely identifies this particular threat. One additional piece of information that particular signature assigns to that threat is the threat level. And there's 5 being the highest threat. So what we then assign is the threat name, the threat family, the platform, and a number. And that number, let's say in this particular case, was 4. 4 out of 5. So it's a really high threat, right? It's a backdoor. And there's different technologies which can also identify this, right? So let's say we have our functional similarity algorithm, right? Which also decides that this file is malicious and it's a backdoor. So similar kind of thing. So win32 again, let's say backdoor, and let's say extreme rat. So something completely different than the signature. So in this particular case, let's say Extreme Rat has a threat score of 2, for example, right? So why are these two different? Well, they're different because signature is really specific. It's meant to identify this specific threat, so it has the highest accuracy. The function similarity algorithm says, well, this looks like Extreme Rat. And the functional similarity algorithm is correct because these are variants of the same threat. So think of them as first version and second version, right? So that's why this is less accurate and less threat, right? So we have two more. So let's say since we have a signature, we also have an unpacker, which is connected to the signature. So we want to be able to process this particular threat. So it's going to create the exact same name as before. So backdoor, and then I'm secure at. And same threat factor, right? So the unpacker and signature do pretty much the same thing. The unpacker just processes the files based on the signature, and therefore the threat name is going to be the same. So these two are in agreement. In our final classification, number 4, will be machine learning, for example, right? Machine learning is a heuristic classification which identifies the threat types. So it will know something is a backdoor, but it will not identify something as a malware family, right? So it will not tell you this is I'm secure rat, it will not tell you this is extreme rat, it will just tell you this is win32.backdoor. .heuristic with a threat score 2. So machine learning is helpful because even if we didn't have a specific signature, even if we didn't have this similarity, even if we didn't have an unpacker, it will still tell us, okay, I'm the only classification and I'm saying this is a backdoor, I just don't know the family, right? So how do we now pick which of these classification engines do we listen to, right? And there's really 3 factors. There's the accuracy. The accuracy is how specific this technology is, and the most specific one is going to be signature, right? It's uniquely identifying this particular threat. How generic is this classification, right? Yet again, specificity, we say signature wins, right? And finally, what is the most severe of these classifications? And the most severe has the highest threat, which is, in this particular case, number 4. So the only one which meets all of these criteria is a signature. And that will be the ultimate result for the classification. So we started with 4 classification engines by selecting the one which has the best possible name, the one which has the highest threat, and the one which is the most accurate. We came to the conclusion that this particular executable, right, is a backdoor, and its family name is I'm secure at. And then by rules of propagation, we also say that this document contains that backdoor and that the zip archive contains that backdoor. So this is how we use our unpacking technologies to be able to detect hidden threats. And the reason why unpacking helps with classification is because it increases the surface, right? It lets us analyze every single file along this way. So if we didn't have unpacking, we couldn't have never gotten to this executable file, and we could never say that this zip archive is in fact malicious and that it's containing a backdoor. So in reality, while talking about unpacking, we're also talking about how it helps classification. These two things are inherently linked together, and only by using unpacking technologies, the engines which do classification have the best possible chance of catching every single threat.